Alrighty, so we are verifying solutions. We're not finding a solution. We are verifying that something is or is not a solution of a differential equation. What makes an equation a differential equation? Is it something we've been working, what? It doesn't necessarily have to be continuous, but have we been working with differential equations all year and just not call them that? Yes, because they are what? They're just derivatives. Okay? It sounds like it's a fancy new thing. It's just a derivative. That's all it is. If I have taken the derivative, so f prime is a differential equation. Okay? Does that make sense? So that part, that's not new. Okay, so then we're going to talk about a solution. A solution to a differential equation is a function, y equals f of x, that satisfies the differential equation when f and its derivatives are substituted into the equation. So we're going to do some substitution, do a little bit of algebra, maybe do some derivatives. Everything we already know how to do, just kind of putting it all together. Okay, so to, again, verify, we can substitute derivatives and the suggested solution into the differential equation. Okay, and again, maybe we have to, and then it says verify. So verify means this is the solution. Show me that is the solution. It is not asking, is this a solution, right? Those kind of wordings and those questions make a difference. So they give me a y equals. So it says, show me that y equals this is a solution to this differential equation. So in order to do that, what do you think we have to find? Okay, so we have y. What else do we need? Y double prime. And before we can find y double prime, we have to have what? Y prime, yes. Okay, so let's find y prime. I'm going to give you a second. I want you to take the derivative of y. Yeah, and don't cheat off your neighbor. What rule do we have to use? Chain rule. You have a function inside of a function. So the derivative of cosine is negative sine. And then I have to take the derivative of 2x, which is 2. That's what I multiplied by that 4. Now, if yours didn't look like this in your first step, that's fine. But what you have should be the same as this or get you to this point, right? There we go. That's what I was waiting for. That's fine. But then because we're going to move forward, so what he's saying is, listen, shh. What he's saying is he had y prime equals negative 4 times the sine of 2x times 2 plus blah, blah, blah. Is that the same thing as what I have? Yes. Okay. And if we were just done with it, we could leave it like this. But since we're going to go forward with this, I would suggest that we clean this up to make it look like that. Does that make sense? So you did it correctly, beautiful, but there are times where you want to take it a step farther, right? And this would definitely be one of them. All right, we all good with that? All right, so then find y double prime. Did we do a little bit better on the second derivative maybe? Once we remembered that chain rule was a thing. All right, is everybody with me? All right, so now we have y double prime. Remember, this is what we are trying to verify. So basically, I'm going to substitute what I have into this. So I have y double prime, which is negative 16 times the cosine of 2x minus 24 times the sine of 2x, then plus 4 times y. Well, y has more than one term, so when I put that 4 there, I want to open my parentheses and have 4 times the cosine of 2x plus 6 times the sine of 2x. And that is supposed to equal 0. And even if you can see what's happening right now, you're verifying, which means you have to show the process, right? Like your work is your answer here. Okay, everybody got it substituted in? So then I'm going to rewrite the first two terms and then distribute that 4. So I get negative 16 times the cosine of 2x minus 24 times the sine of 2x. Then when I distribute, I get plus 16 times the cosine of 2x plus 24 times the sine of 2x equals 0. Okay? And then, well, negative 16 and positive 16 zero out, negative 24 and positive 24. So I get 0 equals 0. And I just verified that that's true. Okay? So they will be kind of like little puzzles. You know what you should get in the end, right? Everybody good so far? Yes? Okay. Any questions? All right, so then example 2, we're going to determine whether the given function is a solution to the differential equation. So this right here. So if I start with A, I'm going to have to find f double prime, right? Go forth, find f double prime. And this question says determine whether. So here your answer could be yes or no, right? It's different than verifying. Okay, so now that we have that, can we substitute it into this? So f double prime is cosine of x minus negative cosine of x. Is this true? No, because this becomes 2 cosine of x, and that does not equal 0. So this would be a no. What questions you got? We good? All right, find the second derivative on B and stop being a 7th grade boy. You too. There was the water dropping, there was the humming, there was the... I didn't say you did anything. Is this the chain rule? Yeah, because you don't have a plain old x up there. If it's not just plain old boring x, it is the chain rule. So If that was just 2e to the x, what's the derivative of 2e to the x? 2e to the x. So I have 2e to the, and that's actually a negative x. Then I take the derivative of negative x, which is what? Negative 1. So I get negative 2e to the negative x. Now find the second derivative. Guess what the third derivative is? Guess what the fourth derivative is? 5th, 6th, 7th, 8th, 9th, 10th. Just keeps on going, right? Okay? Just because you're just going to keep multiplying by that sign there. All right, so then to determine, it was f double prime minus f. So f double prime is 2e to the negative x minus f of x, which is 2e to the negative x. Does that equal 0? Yes, it does. The answer here is yes. All right. Let's do C. Find f double prime. What does k represent? A constant, just a number. So what's your first derivative? K e to the x. So what's your second derivative? K e to the x. Third, same. Fourth, fifth, sixth. The 100th derivative, same thing, right? So k e to the x minus k e to the x equals 0. 0 equals 0. The answer is yes. Okay, I have a funny for you. Funny, right? And girls, this is a lesson. Like, you can't change the guys. Just don't even try. They're all e to the x, and that's fine. Just let him be e to the x. Nobody should be trying to change you either, right? But you ain't gonna change him. Think of him as e to the x, right? You get it? Yeah. But it works both ways, really. You shouldn't ever be trying to change anybody. And don't let anybody try to change you. Okay. Next page. So what does it look like on the AP exam? So it tells you that y equals e to the 6x minus 5 is a particular solution to which of the following differential equations? All right, so to check through all of these, what do you think we're going to need to find? Y prime and y double prime, right? So go through all. So let's do that. We'll just do it up here so we have plenty of room. So y prime, what's that first term going to end up being? Good. 12e to the 6x power. And then the negative 5, that's just the derivative is 0, right? So that means y double prime is what? (72e to the 6x power), right? All right, so in this type of situation, really your only option is to then take those and substitute those into each one of them and see which one works. So this is A, so let's start with A. So y prime, which is 12e to the 6x minus 6 times y, which is 2e to the 6x minus 5 minus 30 equals 0. And we want to see if this works, right? So 12e to the 6x, when I distribute, I get negative 12e to the 6x plus 30 minus 30 equals 0. Now, this is a multiple choice question. Nobody's checking your work, so we don't have to go any farther. Is this a true statement? Yes. So the best test taking strategy is actually to always check every single one of your answer choices. On a question like this, where it's pretty time consuming, Once you find the answer you want, I would say go ahead and go with it and maybe make a little star next to it that you need to come back and check the other ones just in case, right? That way you're not spending too much time on it when you can go get some of the other ones done. All right. But it's possible that we could have made a little error or forgotten to do something and whatever. So that's just kind of a safety thing. But this could be pretty time consuming, right? And so maybe your time isn't well spent here to go through all of them. Maybe it's better spent somewhere else and then you come back if you have time. Okay. What questions you got? All right. Good deal. So number 2 is kind of the opposite of that, of what they're giving you. They're giving you the actual equations and want to know which one of these is the solution to this over here. So for each one of them, as you work your way down, you're going to have to find y prime and y double prime and then substitute them in. So go ahead. I'm going to give you a few minutes to work on this on your own. Now, although I need to write out all my derivatives, and it's safest to actually substitute them each in, you don't, again, because it's multiple choice, we don't have to actually go into that. You can just kind of look at them and think your way through it, unless you get lost in that. When you look at A and B, even if the numbers work out, you'd be adding sine and cosine together. Are those going to zero each other out? Nah. So those are out, right? And then 4 times this one plus this one, not going to give me 0. 4 times this one plus this one would, makes my answer D. Okay? We okay on that? Yeah, because the numbers work out on this one, on B, right? But the sine and cosine are different, so. All right, are we good? What questions you got? All right, do number 3. can double check your derivatives if you want before you go any farther. So. Well, good so far. Now I got a question for you here. Let's see here. Where are your last steps? At the bottom. So how'd you get that from this? Huh? Oh, you were checking it. Oh, I meant here. You put this together. Then did you just guess a number and put it in? Oh, okay. Hey, that I see what you're saying. Okay. Yeah, back there. And the blue one on the top shelf back there. So I wanted to see your last steps. Okay. You're 100% right at this point. Oh, well, that's how far I am too. Okay, so I saw two different things. That's why I was kind of coming around to look at your work. Two different things at this point. Okay, so actually I will write this down twice and then just show you that it's the same thing. And it really depends on what you're more comfortable with and, you know, what you're trying to, just so that you're not doing too many steps at once. First of all, kudos to all of you. I didn't hear a single one of you complain that you had a K in there or pretend like you didn't know what to do because there was a K in there, right? You just jumped in, took your derivatives, and that's exactly how you should handle that. Your rules don't change, right? K is just a constant. Okay, so I saw two different ways to handle this. The first one I saw, which we're trying to solve for K, right? Oh, this should be an X, not a K. Sorry, I'm making stuff up. That's an X. Okay. Well, now it looks weird, but whatever. The first thing I saw was, since we're trying to get K by itself, we can divide the entire thing by this, which totally works, but not everybody's always comfortable doing it all at once, and that's okay. That's okay. And then these cancel out, and this gives you 1/2. I also saw where some people did this, canceled that out, so you get K times e to the negative 2x equals 1/2 times e to the negative 2x. Then you can see what K is, or you can divide here, and that's how you actually get it out of there. And then another way that I wouldn't even have thought to do, that's why I was like, how the heck are you doing this? If we get to the part where it's in green, then you can substitute in your answer choices and figure out which one works. That works as well. Okay? Yeah. I wouldn't have thought to do that, but yeah. Yeah, that's the easiest way if your answer is A, and if the numbers aren't too terribly crazy. So just remember that. Like, it's fine that you do that, absolutely. But we also want to at least know how to actually find it. That way, if the numbers do get weirder, or we have to go through all of, or you try all of them and none of them work, and then you're like, I don't know what's going on. I don't know, that happens to me sometimes. All right, we good so far? Good deal. All right.